Yeah, this is another function here, partial derivative function. Let's say we are asked to find the partial derivative with, let's say, uh, with respect to y, with respect to y. So it means that x will remain constant or remains a change. Else will be equals to constant. So x is not changing. So now um, getting the notation of a partial derivative for y. So let's say partial derivative function f and a partial derivative of y. So with partial derivative of y. So say with respect to y. So it means that x remain constant here. Okay, what I will do is to solve this problem term by term. So this is a term here, this is another term. So first of all, let me move this um, y to the power of 2, bring it to this side. So um, y to the power 2, sorry, okay, this y to the power 2, so move it here. So y to the power 2. So this y to the power 2 becomes, if we are using the power rule, so the power rule means that this 2 here will come in front of this y here. So it becomes 2y, then 2 here minus um, 1, which is equals to 1. So everything here will become 2 raised to power y, because if we use the power rule, which is n minus 1, and the n here is 2 minus 1, and we have 1, so we have just one y here. So here the x remain constant, so we have our x here, so which is a multiplier also. We have x to the power 2 multiplier of 2y plus this whole term here. So we can bring it down here. First, let's break it down, which is 4y raised to power 3, and this means this will become just this 3 will move in front of 5, so we'll have 4 multiplied by 3y raised to power 3 minus 1. So everything here will become 2 here. So this will become 4 times 3 raised to power y raised to power 2. So that will become 12 y raised to power 2. So automatically let's move this down to this place, which is 12 y raised to power 2. And here we have as a multiplier sign here, so we say 2y multiplied by x raised to power 2 will become 2 x raised to power 2y plus 12y raised to power 2. So with this we have succeeded in finding derivative with respect to y, while this x here remains constant.